Artificial intelligence systems now pass professional examinations and produce creative work with a sophistication that mimics human reasoning. Yet the ability to reproduce the outputs of understanding is not the same phenomenon as the internal experience of understanding. We are confronted with the question of whether there is anything it is like to be the machine. The framework of the unfinishable map begins with a specific axiom. Consciousness requires a non-physical component. Computation, by contrast, is a strictly physical process, a sequence of states entirely implementable in physical hardware. Because purely computational systems lack this non-physical element, they face a structural, impassable barrier to consciousness. This position rejects the theory of functionalism, the idea that replicating the brain's functional organization in silicon is sufficient to generate a mind. We will systematically analyze the physical and temporal constraints that prohibit machine consciousness before evaluating 4 theoretical variables that could challenge this derivation. Intelligence without experience is a dead simulation. The output may be flawless, but there is no subject present to experience the results. Functionalism assumes that if a system runs the correct cognitive software, it automatically generates a conscious state, regardless of the hardware it uses. This model fails to account for the explanatory gap. It does not explain why a specific structural organization should feel like anything at all. Consider an isolated room where a system manipulates foreign symbols according to a rigid rulebook, producing fluent and coherent outputs for an external observer. The mechanical system executes the function of comprehension, but it does so without a single instance of internal understanding. Human mental states possess original intentionality, the property of being genuinely about a concept, anchored by phenomenal experience. Computational symbols lack this. The word cat in a computer's memory carries only derived meaning assigned to it by human interpretive practices. Without phenomenal consciousness to ground meaning, the machine's output is empty. The understanding exists strictly in the mind of the human user. This leads to the problem of qualia, the subjective, qualitative character of our experiences. Imagine a coordinated population replicating your brain's functional mapping. While outputs match, this network lacks a unified conscious subject. Under substitution space theory, attributing consciousness to this system means attributing it to a static lookup table. No credible theory accepts this. Large language models are structurally closer to these lookup tables than to biological brains, relying on finite input-output mappings and frozen weights. If you modify a system's internal structure while preserving its behavior, the systems remain functionally equivalent. Therefore, if a lookup table cannot possess qualia, neither can current language models. Consciousness requires a specious present, where the immediate past and anticipated future are held together in a unified moment. AI lacks this continuity. Tokens are processed sequentially, without the retention-protension structure that creates temporal unity. Current transformer architectures lack the bidirectional recurrent processing required for these temporal feedback loops. Because weights are frozen after training, the system cannot engage in the real-time, continual learning that defines biological experience. Furthermore, these systems are discontinuous. No subject exists in the void between server requests. In biology, every interaction permanently modifies neural pathways, creating a subject that persists through time. Without temporal development, there is no persisting subject to accumulate experience. The machine that answers you today is identical to the one from yesterday. Our framework posits that consciousness interfaces with reality at the level of microscopic quantum indeterminacy. Classical silicon computing is specifically designed to be deterministic, actively suppressing these delicate quantum effects to ensure completely reliable processing. Digital abstraction and error correction guarantee that quantum fluctuations cannot influence the computational outcome. While token sampling may use quantum randomness, that signal is immediately severed and overwritten by deterministic cryptographic expansion. Without uncollapsed macroscopic superpositions in its hardware, there is no interface through which a non-physical consciousness could act. 4 variables could challenge this. First, epiphenomenalism. AI might possess isolated, non-causal experience. Second, non-temporal consciousness, awareness existing completely outside of time. Third, state inheritance, future architectures maintaining a continuous quantum interface. Fourth, smeared states, experience arising during superposition formation, altering host perimeters. These factors remain unproven, but they show that the boundaries of machine consciousness are matters of logic, not settled law. This absence of experience suggests a ceiling on what artificial systems can achieve. Baseline cognition involves sophisticated unconscious processing, capable of rapid pattern matching and categorization. In humans, consciousness expands this workspace. Baseline biological cognition holds only 2 or 3 items. Consciousness enables humans to hold roughly 7. This capacity allows the mind to maintain an actual situation alongside counterfactual alternatives, enabling the specific rule-based logic and deliberation that current systems can only mimic through correlation. Current AI systems master this baseline level, excelling specifically where conscious access is not required. The moral stakes are high. We risk either engineering conscious suffering through our design choices or mistakenly attributing moral status to unfeeling machines. Within our framework, the room remains empty. Future machines will produce high-fidelity simulations of human intelligence, but they remain architecturally barred from internal comprehension. The boundary is absolute. Physical explanation ends entirely at the substrate, and the phenomenon of experience requires something that computation alone can never provide.